Bismillahirrahmanirrahim. Assalamu alaikum, students. I hope you will be fine and enjoying good health. So it's our fourth week of the subject uh, PHY 132 of electricity and magnetism. And in last lecture, we started the topic of electric field, and we discussed the electric field generated or electric field uh, due to the point charge, electric field due to dipole, and electric field due to line of charge or disk of charge. So these are the, you can say that the different electric fields being generated by the different you can say that the charge distributions. So today we'll discuss the electric uh, force which is being exerted uh, when an object is placed in an electric field. So in that situation, I primarily just write down the overview of the previous articles, what we have discussed so far, and then we'll move on to the next article related to the electric force being generated or being observed by a charge particle or the distribution of charge when placed in an electric field. So now I just want to write down the overview of what we have discussed so far. So we started with electric field. Is just the summary of previous lectures, you can say that. So we actually discussed two main things. The first thing was the production of electric field by a distribution of charge. So in that category, we discussed the field which was produced due to a field due to a point charge. We also discussed the field due to a dipole. We also discussed the field due to line of charge. And lastly, the disk of charge. So these are the articles that we have discussed so far. Once we are dealing with the first heading, first umbrella, you can say that, of the electric field, in which we discussed that the production of electric field by a distribution of charge, that what kind of electric fields is being generated or produced by the charge distribution, single charge or different charge distributions, you can say that. So the second thing is actually the force that a field exerts on a charge placed in electric field. So in this situation, we have primarily discussed this one with respect to the electric field produced by different charge distributions, and these are the articles which are being covered 22.4 to 22.7 of chapter number 22, that is related with the electric field. And today we'll discuss the different articles related to this force and we'll mainly emphasize on the applications, that how these forces and these concepts of electrostatics related to the generation of electric field and the electrostatic force are helpful in our daily life, and what kind of you can say that applications are there where the basic ideas of electrostatic force electrostatics they are being applied. So the first article that is actually under the umbrella of this force is a point charge in an electric field. And the second thing is a dipole in an electric field. So these are the two articles that we will primarily focus in today's lecture, and try to emphasize on the fundamental concepts, fundamental relations that are being used in certain applications. So we start with the first one. This one is actually the article 22.8, and this one is 22.9 of chapter number 22. So we start with the first article, that is a point charge in an electric field. So in this situation, we have already discussed that once a point charge is placed in an electric field, then it actually observe an electrostatic force. That electrostatic force is actually equal to QE. So when an electrostatic force acts on a charged particle, then we can say that the force is equal to F is equal to Q into E. That is the electrostatic force which is actually being exerted on a charged particle when it is placed in an electric field. So I can just write down over here electrostatic force. That is charge Q actually experiences once it is being placed in an electric field. So we have already discussed that this electrostatic force is having the same direction as that of electric field when the charge is positive, and this force is having an opposite direction as that of electric field once the charge is negative. So just write down that main point for our understanding, that this electrostatic force on a charge placed in electric field has the same direction when charge is positive and opposite direction of electric field when charge is negative. So in this situation, you can say that if the charge is positive, then the force is having a same direction as that of the electric field, and when the charge is negative, then they are in opposite direction. So these are actually the fundamental, you can say that the points that we already know in case of electrostatic forces when it is being exerted on a charge Q and which is placed in an electric field E. So in that situation, this Q is actually equal to NE. That Q is equal to NE, that what we have already discussed in chapter number 21 in case of quantization of charge, where E is actually the elementary charge on electron. That is 1.6 into 10 raised to minus 19 coulomb, and N is the number of electrons which are being placed in an electric field. So utilizing this basic concept, actually we need to emphasize on the measurement of the force exerted on the charged particle, and how this force is useful in our daily life, and how we can utilize the basic ideas of the electrostatic forces being exerted on these charged particles to our applications, or to apply in our devices. So if we say that first we need to actually measure the elementary charge. What is the actually charge on an electron? So that is the you can say that the point to measure the elementary charge. So we are already familiar with the method which is used to measure the elementary charge. That was Millikan oil droplet method. So I just share with you the diagram of that measuring that Millikan oil droplet method. So if we focus, so this one is actually the diagram which is showing us the Millikan oil droplet method. The chamber, it actually consists of 3 chambers. And this one is the experimental setup of the Millikan, which he used to find out the elementary charge on a charged object. So primarily it is actually the method to give us the value of the elementary charge on an electron. So this one is the method being used by the physicist that was Millikan. He actually used a chamber. It was actually partitioned into 2, chamber A and chamber C, and in chamber A he actually sprayed some oil droplets, and these oil droplets actually then after a certain time it was allowed to enter 1 oil droplet into chamber C. So in this situation, this chamber C was connected with the battery through this key K, and in this situation we can say that there are 2 walls. One wall is at point P2, the surface P2, and the other connection was with P1. So P1 was actually positively charged and P2 is negatively charged. So in that situation, if the battery is off, so there is no electric field being applied across these 2 walls, P1 and P2. So once there is no electric field, so this oil droplet which is actually charged, you can say that oil droplet will not actually experience any electrostatic force. So once the battery is connected, this switch is closed, then accordingly this plate P2 will be positively charged and P1 will be negatively charged. So this droplet, if it is negatively charged, it will move towards P2. Okay, and if it is positively charged, then it will move towards P1. 1, because the negative charges, they repel each other, and opposite charges, they attract each other. So based on the charge on this oil droplet, the electrostatic force will be actually applied on it. If the charge on this oil droplet will be more, then the more electrostatic force will be applied, and if the charge is less, then accordingly the less electrostatic force will be applied on this oil droplet. So based on the you can say that the charge on this oil droplet, actually the movement of the oil droplet, or the drifting of the oil droplet towards plate P1 or plate P2, can be estimated by this process. So he actually utilized this concept, this apparatus, to find out the charge on an electron, the elementary charge on an electron. So in this article, actually they mainly the apparatus of this Millikan oil droplet method was shown, and in that situation he actually estimated or calculated the charge of an electron. So now I just write down the main points of the experiment, what the Millikan actually did this. So I just write down this one as Millikan. This one I think you have already studied in your FSC also. Oil droplet method. So as this equation of electrostatic force F is equal to Q is actually is the fundamental force which is playing its role in the measurement of elementary charge, and the figure that we have shown, we discussed so far, that actually figure describes the method how the charge on an electron can be estimated. So in that experiment, the charge was considered to be negative. So first thing that he started to you can say that the assumption with the charge to be negative. Okay, so if the charge is negative, it will be attracted towards a positive plate. So I can say that over here it will be attracted towards positive plate. Okay, and in our situation the positive plate was P1. Now I just write down the main step. The chamber C, where the oil droplet was entered, consists of positive and negative plate which are connected with the battery. So after the you can say that the application of the electric field, if the plates are connected, field is being applied, then the charge will be attracted towards the positive plate. So the negative charge will be attracted towards positive plate, and vice versa. If it will be a positive charge, then accordingly it will be attracted towards the negative end of the battery. Normally we use the you can say that the word of drifting, the movement. It's not a, you can say that a straight movement. You can it's kind of a the movement having a collisional effect. So in that, in such type of movement, we can say that it is drifting towards a specific direction. So as this oil droplet also can have the collisional effect with the molecules or the walls of the with the other you can say the particles in the atmosphere. So in that sense we can say that it is drifting. It's just like the same situation that we consider for the conductors. If the free electrons they conduct from one place to the other place, right? So it's not a motorway that there is no electron in the path of the moving electron. So it's actually a collisional effect, and after the collisional effect the net direction of the movement of the electron is being estimated or being specified, and that net movement after the collisional effect is considered, that is the electron speed or electron velocity, and that is actually termed as drift velocity. So means that if the velocity or the speed of an electron is directed in specific direction after the collisional effect with the surrounding electrons or the other electrons in the material, then accordingly we can say that it's a drift velocity, right? Is the net velocity of a charged particle in the material. So in that sense we can say that it is drifting rather than movement. We could just utilize the main word of drifting towards positive plate or drifting towards the negative plate. So by utilizing the basic idea of the interaction of the charged particle and the electric field, Millie can actually estimated the charge of an electron. So I just write down over here the main core point, that the interaction of electric field and charge placed in that field resulted in the estimation of elementary charge having value 1.6 into 10 raised to minus 19 coulomb. So primarily this one is the main theme, that how the interaction of electric field and the charge placed in an electric field will give us a useful information, and how that useful information being implemented in different applications. So primarily it's an interaction between the charged particle or the object, a charged object placed in an electric field, and the electric field exerts a force. That force is equal to Q into E. If it is in case of electrostatics, then that force is actually being responsible for the drifting of the charged particle based on the electric field being generated across the charged particle. If it is positive charged, then it will be drifted towards the negative plate, and if it is negatively charged, then it will drift towards the positive plate. So in that situation, utilizing the basic equation of electrostatic force, we can estimate the elementary charge of an you can say that of an electron, you can say that. So in this situation, if the Q is equal to Ne, right? So N is the number of particles, number of charged particles. We just place it over here. We know that how much force, how much electric field is being generated over there, and based on that electric field, we know the force, that how much force that electric field will exert, and just utilizing the basic you can say that the equations, we can find out the value of E. If I just put the value of Q is equal to Ne in this equation, Ne, right? So we applied a battery, and a battery is having a specific voltage, and it will generate a specific electric field, and that specific electric field will generate a specific electrostatic force. So we know the electric field, we know the electrostatic force, and based on this information, Q is equal to Ne. If the number of particles is 1, then we can just put 1, 2, 3, 4 over 5, whatever are the number of particles in this you can say that if the material which is under consideration, then all the values are known to us. Then we can find out the value of elementary charge, and that what did actually the Millikan using the basic ideas of electrostatic and using the basic equation of electrostatic force, that is F is equal to Q into E. So this actually you can say that the basic concept resulted in the estimation of the estimation of charge of an electron. So do you have any idea that how the mass of an electron has been estimated? Because there is no such a small weighing balance which can give us the information of the weight or the mass of an electron, राइट कि हमारे पास ये जो है ना वो इतना नहीं है कि हम इलेक्ट्रॉन को किसी वेइंग बैलेंस के ऊपर रख के तो उसको कहेंगे जी अब इसका वजन जो है ना वो कितना है, ठीक है. इट्स नॉट लाइक दैट. तो ये इलेक्ट्रॉन मास इज वेरी वेरी स्मॉल. सो व्हाट वी डू, वी एक्चुअली फाइंड आउट द चार्ज टू मास रेशियो ऑफ एन इलेक्ट्रॉन. व्हाट वी हैव एक्चुअली परफॉर्म, आई थिंक यू हैव परफॉर्म द एक्सपेरिमेंट इन योर प्रीवियस सेमेस्टर, दैट the determination of charge to mass ratio of an electron by deflection method. So charge to mass ratio of an electron can be estimated. The charge of an electron is actually being measured by the Millikan-Isle droplet method. Then charge to mass ratio is known to us, and from that we can estimate the mass of an electron. So it's actually these two values are these two actually parameters which can give us the value of the mass of an electron. There is no direct method to find out directly the mass of an electron, just like the method which we are using for the estimation of charge on an electron. मतलब जिस तरह हम लोग चार्ज ऑन इलेक्ट्रॉन जो है ना वो एस्टिमेट करते हैं, उसी तरह हम लोग को मेथड से mass of an electron मेजर नहीं करते, बल्कि चार्ज टू मास रेशियो की वैल्यू फाइंड करते हैं, और चार्ज टू मास रेशियो की वैल्यू में चार्ज की वैल्यू पुट करके तो हम लोग मास का जो है ना वो इलेक्ट्रॉन की मास की वैल्यू हम लोग एस्टिमेट करते हैं. तो इस तरह चार्ज टू मास रेशियो ऑफ इलेक्ट्रॉन जो है ना वो प्राइमरीली हमें मास ऑफ एन इलेक्ट्रॉन को मेजर करने की इंफॉर्मेशन देता है. उसे हम लोग मास ऑफ एन इलेक्ट्रॉन मेजर कर सकते हैं, राइट. तो यहां से एक चीज तो ये वाजे हो गई कि अगर एक चार्ज ऑब्जेक्ट किसी भी इलेक्ट्रिक फील्ड में आ जाए तो इलेक्ट्रिक फील्ड ने उसके ऊपर फोर्स एक्सर्ट करनी है, इलेक्ट्रिक फील्ड ने उसके साथ इंटरेक्ट करना है, ठीक है. लेकिन ये जो फंडामेंटल हमारे पास आइडिया है, ये जो कॉन्सेप्ट है, ये जो अंडरस्टैंडिंग है, इसको हम यूटिलाइज कर सकते हैं. इसका मतलब क्या है कि अगर हमारे पास एक जो ना वो जगह के ऊपर चार्ज पार्टिकल्स मौजूद हैं, लेकिन हर एक की जो है ना वो एनर्जी, हर एक की वैल्यू जो है ना वो डिफरेंट है, तो उसके ऊपर अकॉर्डिंगली इलेक्ट्रोस्टैटिक फोर्स भी डिफरेंट लगेगी. तो जैसे ही वो डिफरेंट लगेगी तो उसके अकॉर्डिंगली उनकी मूवमेंट, उनका इलेक्ट्रोस्टैटिक इंटरेक्शन जो है ना वो डिफरेंट होगा, ठीक है. तो उस डिफरेंट इलेक्ट्रोस्टैटिक इंटरेक्शन को हम लोग जो है ना वो यूटिलाइज कर सकते हैं, और इसकी जो एप्लीकेशन है, ये जो खास तौर पे पॉइंट चार्ज के हवाले से इसकी एप्लीकेशन जो है ना वो हम लोग लेते हैं इंकजेट प्रिंटिंग में ना. सो आई जस्ट राइट ऑन द नेम ऑफ इंकजेट प्रिंटिंग. इंकजेट प्रिंटिंग. This is actually the you can say that the application of the basic idea of interaction of electric field with a point charge. अगर पॉइंट चार्ज के साथ इंटरेक्ट करवाना है तो उसके साथ उसकी जो है ना वो इंटरेक्शन को, उसकी मूवमेंट जिस तरह डिस्टर्ब होती है वो इंटरेक्ट करता है. उस बेसिक आइडिया को, बेसिक कॉन्सेप्ट को यूज़ करते हुए हम लोग इंकजेट जो है ना वो उसकी प्रिंटिंग में यूटिलाइज करते हैं, और उसके अकॉर्डिंगली हम लोग इंकजेट प्रिंटिंग में यूज़ करते हैं. तो ये जो इंकजेट प्रिंटिंग है, ये हमारे पास यही समझ लें कि हमारा जो है ना वो नॉर्मली पीछे हम लोगों ने एक एप्लीकेशन पढ़ी थी जिसमें हमने फोटोकॉपी का जो है ना वो कॉन्सेप्ट लिया था कि हाउ द इलेक्ट्रोस्टैटिक्स और द चार्ज स्प्रेड ऑन द इंसुलेटर और सेमीकंडक्टिंग मटेरियल इज एक्चुअली रिस्पॉन्सिबल फॉर द फोटोकॉपिंग, ठीक है. उसका प्रिंसिपल क्या है, जिसमें हमने चार्ज स्प्रे किया था और उसका जो है ना वो इंक को हमने एक स्पेसिफिक चार्ज दे दिया था, और वो चार्ज जो है ना वो फोर्स ऑफ अट्रैक्शन और रिपल्शन के थ्रू फोटोकॉपिंग मशीन जो है ना वो उसके अकॉर्डिंगली हमने इसको बड़ी डिटेल में डिस्कस कर लिया था. अब यहाँ पे इलेक्ट्रिक फील्ड और जो चार्ज है उसका इंटरेक्शन यूज़ करते हुए किस तरह हम लोग जो है ना वो इंकजेट की जो प्रिंटिंग है वो उसको यूज़ करते हैं. ये एक्चुअली जो है ना वो इंकजेट प्रिंटिंग चूँकि मॉडर्न हमें बहुत फास्ट स्पीड में जो है ना प्रिंटिंग चाहिए होती है. सो दैट फंडामेंटल कॉन्सेप्ट ऑफ दिस electrostatic field and the charge interaction being utilized in such kind of printing, in which we have high speed printing, and that has actually printing has caused a search for an alternative to impact printing. That can be, you can say that, used in a standard typewriter, or you can say that the building up letters by squirting tiny droplets of ink at the paper is just used as an alternative. So in photocopying machine, the ink particles were charged. Over here the ink droplets will be charged, and utilizing these ideas of Millikan oil droplet method, in which the charge droplet is being, you can say that, placed in an electric field, and then accordingly it will experience a certain electrostatic force, and that interaction will result in the drifting of the charged particles from one place to the other place, and that basic concept will be utilized in inkjet printing.